with a small company, and we were working on a small tech company. And when you're managing physical server, you need to have experts with networking, with hardware, with operating system, and then developer. And then when something went wrong, we were all gathering in a war room, and trying to figure out what's wrong. And then it worked out fine, but as the company grew bigger, we started having SLAs to customers, and then we needed to build a dedicated NOC and supporting. And this was a real challenge because as a founding team, we had all the knowledge we needed. But then when new people in the organization need to do the troubleshooting, it's always hard to transfer all the knowledge. And this was a challenge throughout the life of the company. It always was a challenge. New people kept coming in, and then transferring the knowledge was an issue. So this is when I first understood that the real challenge in troubleshooting is having the right knowledge at the right time. If you know what to do, it's easy. If you don't, you get tough. Fast forward 10 years, the world has gone through a big transformation. We transformed from physical machines to VM to container. And then it was about 2017. Kubernetes was a big thing. We were working on a startup which did Kubernetes security. But while doing that, we found out that Kubernetes, while it's a great platform, the learning curve to use it is really, really steep. And then our own developers had always issues with how to operate with Kubernetes. We had like one DevOps engineer, and he couldn't handle the load. And then we saw the same issue happen to all of our customers. And that made us thinking like there's got to be a better way to operate data operation in Kubernetes. And it led us for the idea for building a Robusta. So on early 2021, we started to build the company. And we had a simple idea. We wanted to build a runbook automation platform. And we wanted to take the steps an expert SRE would take for every incident and to transform it into code. Now, before Kubernetes, doing this kind of platform was practically impossible because before Kubernetes, when you write logs in application, everyone is doing it in a different way. So if you want to build an automation that collects the logs, it's really, really complicated. Same goes for scaling, for networking. Kubernetes provided a unified interface that you can work with, and then you can build a unified platform that works for everyone. And then everyone used Prometheus to monitor Kubernetes, which gave us another data source. So it was a really good base to build the company. And we made the project open source. We wanted to have a really simple architecture. So it's like an event-driven platform. We had two data sources for event. One is the Kubernetes API server, and the other one is Prometheus, where we got alerts. And then these events were fed into the automation engine. And then for each type of issue, we were running automatic procedure that will analyze the issue and then send the results to the many different integrations. So we integrated with Slack, with Teams, with PagerDuty, and wherever you consume your alerts, we will send the alerts to them. So the core concept of the platform were playbooks. The playbooks basically have three parts: trigger, which means when you want to run. So we had triggers based on Prometheus alert. So you can run whenever a specific Prometheus alert is firing, an alert on a given deployment. You can really filter when you want to run. We have triggers for API server events, so you can run whenever something is changed. So you can define whenever someone is changing my ingress, I want to run an automation. And second part is action, which is basically what you want to do. So an action most of the time is like an evidence collection. So whenever you have a code that is pending, you will collect evidence why it is pending, and then you will send it to the destination, which is the sink. Actions can also be a remediation action. So you can define an action that actually fixes things. So the most common remediation is just restart the pod. but you can also launch a Kubernetes job that does something, do some cleanup on the database or whatever you want to do. So the platform was really flexible and easily flaggable. And like people really love it. Today we have like, I think, above 1,000 companies that are using the platform on a regular basis. And here is some example why it's valuable. So this is an example for QPod not ready alert. On the left, you see what you get directly from Alert Manager, which basically gives you the alert with the label. And on the right, you have what you get from Robusta. So when you got this alert, like QPod not ready, what did you do in order to understand what's happening? Does anyone know? So
describe the events.
Sorry?
Describe the events. Or
yeah, exactly. So you go and run kubectl get events, and then in the events, most of the time you see why the pod is not ready. So basically, the system does it for you. It goes, takes the pod, it runs kubectl get events, and then it attaches it to the message. And then when you get this message, you already know why the pod is pending. Another example would be when a job is failing. So when a job is failing, you basically want to see the log of the pod, and then you want to see how much time the job is running, how many times it failed. So Robusta basically gathers this information automatically for you. And then another reason why it's useful, sometimes the job is running during the weekend, and then when you come to the office on Monday, the job is not there anymore. And then in order to figure out what happened, you need to do digging. So here you have it like it persisted. It persists a snapshot of the situation when the alert happened. So this was great, people really loved it. And then they were starting to ask for features. So they were telling us the enrichments are great, but routing on a ton of alerts in Slack is not very useful. We want to have a better way to see the alert history. Some people use Robusta to track changes, and they said, okay, we want to see changes over time. We want to see correlation with alerts. And many users said they're monitoring multiple clusters, and they don't have a good way to visualize everything. So we built the SaaS platform, which basically, this is how it looks. So you have like a global timeline. You can filter on any cluster. If anyone is doing a change, you can see the actually did change. And you see all the alerts and all the context that was get. Okay, then in early 2023, ChatGPT came to life, and then we were starting to think, how can we improve Robusta by using the ChatGPT? Before ChatGPT, we had like a special action, which we call the Stack Overflow Enricher, which means you can add to alert a button, and then if you don't know what to do with the alert, you click the button, and in the background, it runs a query, like a search in Stack Overflow, and then returns the result into Slack. And it was useful. If you don't know what to do, you get some Stack Overflow answers, and it's nice. And we thought, why don't we do it the same with the ChatGPT and try to see if we get better results? And the results were really much better. I can show you an example of how it looks. So here I'm simulating Elasticsearch heap usage too high. And then you get it in Slack and you have the label. We don't have specific enrichment for this one. So if you're not sure what to do, you can click the button. And then if it works, you'll get a result from ChatGPT, which tells you basically what is this alert, why it is firing, what are the common causes, how you can troubleshoot it, and what's the possible solutions. So this really improved the quality. And then the problem with it is that the results were too generic. So basically what we did in the first integration, we sent ChatGPT the alert name and asked what do we need to do about it. But the results were generic. It was like an Elasticsearch, whatever, for any given alert. It had nothing to do with your specific instance. And then we thought about, and then we know, first of all, Robusta has access to get information from your cluster. And we also have all the enrichment we collect. And then we thought, why don't we take all this data and send it to ChatGPT, and then he can give better answers about your instance, what is happening. And the results really improved a lot. We were gathering logs and events and so on, and send it to ChatGPT along with the description of the incident, and the results improved a lot. So we saw that there's a big potential that LLM can really provide great value, and then we went back to the drawing board and thought, how can we really use the power of LLMs to really get something special? So basically, LLM can do two things very well. So first, you can give it a big chunk of text, and it will easily get the important insights of it. It does it really, really well. And then the second interesting capability is called tool calling. So tool calling is basically the capability of LLM to take your inquiry and then to convert it automatically into an API call. So a good example would be, let's say you go to ChatGPT and you say, I want to book a room in Johannesburg, a hotel room next week. And ChatGPT will actually return very accurate results. So the question is, how can you do it? Because ChatGPT, depending on the model, is trained on very old data. So how can you know what is happening today? And the answer is it uses tool calling. It takes your inquiry, it converts it to an API call using a tool. In this case, it's a browsing tool. It runs a query, and then it can return an answer with dynamic data that you need. And we said, why don't we take the same approach in investigation? We'll give the LLM tools for investigating. We'll give him tools to check what's happening with Kafka. We'll give him tools to check the log, to check Kubernetes event. And then like the LLM will decide which tool he needs to call for the investigation, and then returns the actual root cause of the issue. This is like basically very similar to what a human would do. You get an alert, and then you figure out, okay, what do I need to do next? And then you do it, and then you try to understand what's going on. So with that approach, we went and built Holmes GPT, which is an open source tool. Like it's a DevOps investigation tool, which is based on tool calling. So basically, you can connect any tools you want. This is basically how you define a tool. So this is a tool for kubectl describe. You're saying the tool is for describing a Kubernetes resource. You describe the command, and then the LLM knows to take your inquiry and convert it into an API call. And then we equip it with many different tools, and then you'll get really amazing results of investigation. So what you can do with Holm, you can ask questions about your infrastructure, what's wrong with my Kubernetes cluster. You can ask to analyze why a Prometheus alert is firing. You can check if any of your microservices is healthy. You can ask actually for fix suggestion, and you can do a lot more. We have customers trying it with security use cases. It's really flexible and has really interesting capabilities. Let me show you some examples. So this is a demo cluster. It has basically a lot of issues, and I'm asking the LLM to explain what is wrong with my cluster. Now, it's not a predefined step he needs to take. Like the LLM decides which API he wants to call, which tool basically, and then he will get responses, and then he will call other tools until he has a satisfying answer. Okay, so ChatGPT return 3 results. I'm actually looking for the fourth, which is sometimes not shown, but okay. Let's give him another minute.
Demons.
Yeah. Basically, it's a crashing pod, so it doesn't find it every time. So, okay, so we have like 4 crashing applications, and then I can ask more interesting questions. So, I'm asking what's wrong with my account config and how can I fix it? And now the LLM is choosing to run completely different tools. And I don't know what is it's going to run, but hopefully will tell us what's wrong and really how to fix it. Okay. So the LLM said, which is correct, that the pod is not running because it has like a node selector with a node that doesn't exist. And then in order to fix it, either I remove the node selector or I will add this label to the node. And this is actually what you need to do, which is really good because he thought on the answer on his own completely. Let's see another example. So this is basically an example how you investigate one of your Prometheus alerts. Hosts can connect to any of your ticketing systems like Jira or whatever you use, and then to pull alerts and to investigate it, that gives you the root cause analysis. Okay, so here we have a job that is failing, and then the LLM found the relevant job and then checked the job log. And now you see that in the logs, there is the error that caused the job to fail, which is basically it couldn't connect to the database. Any questions so far? Comments?
Have you ever seen examples where it gives you a wrong hallucination, like a completely wrong solution, like
yeah, absolutely,
like so, larger cluster.
Yeah, so the LLM is not perfect. It does hallucinate every now and then. We work a lot in order to minimize it. It's not perfect yet. You still need to have a human in the loop. So you need to look at the result, and then we think that the on-call person doesn't know everything he needs to do, but we count on him that he will know to identify something that is completely wrong. But it doesn't happen a lot, and we like improve it all the time.
There's another question back here, I think.
Yeah, sorry.
Yeah, I was just wondering. So then you secure your kubectl with a limited access, like
yeah, like we start at the beginning. We start to give it just kubectl, run whatever you want. But then we said we work on production system, and like I don't know what LLM decide to run. I want to limit what it can do. So this is why, like, even though we can say to the LLM, this is kubectl and go run whatever you want, we're limiting it to read-only operation. So you can do describe, you can do log, you can add other stuff.
So this is as part of the agent that is in cluster.
Yeah.
And then it runs as a service,
Yeah, exactly. So you can run Helm if you run it from the CLI. So it will take your user credential and it will get your permission. And if you're running it in a pod in the cluster, it has a dedicated service account. Okay. And you can control whatever you want. Okay, so we built the open source CLI, and then we said, okay, how can we integrate it into the Robusta platform? So ideally, you want, whenever you get an alert, you can click a button, and then Helm run in the background, and then gives you just the root cause analysis. So we did it. We integrated an option to investigate alerts, to investigate the health of a microservice. And then you also have like a chatbot, which is equipped with your tool. And then you can just have a conversation and see what it's on. Let me show you some examples of how it looks.
Arik, can you make the text bigger? Maybe just be my old eyes.
Yeah, I can.
The space in the front.
Naughty schoolboy, and I all sit at the back.
Is this better?
Yeah.
Okay. This is like an alert. Let's look at one alert. And then I'm going to go into one. And then once you click it, you have here the root cause tab, which basically runs automatically. And then it tells you why the alert was firing. This is like a rollout stack alert. We don't have too much information other than the alert label. And then Holmes check it, and then it says this is not working because it cannot find the image, which is actually the root cause. Let's see another example. This is like a microservices view. It shows you all the services across the different clusters and then the issues that collected on them. And then if you drill down to one, it has like a diagnose button, which basically run Holmes in the background. And then it tells you that the pod is not healthy because there are not enough CPUs and memory in the cluster. And now the last example that I'm going to show you, I'll go back to the apps view. I have a Redis key value store here, and it looks not healthy. And then Holmes is telling me that the PVC, something wrong with the storage class. Okay, I'm gonna zoom out to see, to be able to see the chat in a second. Okay, so here Holmes is telling me the PVC cannot be provisioned because there is no storage class. So I can go ahead and ask what is a storage class, if I'm not sure. And this goes back to Holmes, sends all the context, and then. Okay, so Holmes gave me an answer, what is a storage class? I can ask what storage class do I have in my cluster? So it says I have only the GP2, and then I can go ahead and ask, how can I pick the PVC to use GP2? Okay, so it actually gave me the manifest I need to fix with the updated storage class. So because I equipped Holmes with tools which actually can do queries on my cluster, I can get really accurate answers about my issues and how to fix it. Any question?
So is it showing? Is it? I'm trying. Next. Next. Okay, thank you. Is the manifest here the one that you have in production, and it's just showing you what needs to be updated?
It shows me the entire manifest of the PVC.
That's currently what's installed, and that's the line that highlights is what you have to change.
Yeah.
So it's able to read, it's able to fetch the existing manifest and telling you exactly the recommendation you want to change.
This is the actual PVC configuration in my cluster.
Okay.
Like the original one is with the storage cluster standard v2. Yeah.
So I've got two questions. They're probably both stupid. The first one is it just for infrastructure? Like it can't actually go into like the application layer. It's just infrastructure.
No, it can. So it all depends on the tool you provide. So like you can say whatever you want. If you want anything you can do with you can create a tool for it, and then also you'll be able to use it.
So it could potentially pick up like if you disconfigured application or your infrastructure.
Yeah. I will show some examples in there, like about the application troubleshooting.
Okay. And then the second question, I'm just confused. Where's Homes running? Is it running in the cluster or is it external and we're just giving it credentials to?
So here it's running in the cluster, it's running in a pod. Like, and then when you click the buttons, we handle the wiring and then we send the request to Homes, it does the investigation and return. When you run it in a CLI, so you run it on your laptop, and then it uses the kubeconfig to run commands on the cluster. So it can run in both modes. Any other question? Yeah.
I have a question, but I don't know the truth. I'm just wondering, like, what is the LLM that means?
So Holmes can work like she asked what LLM is used here. So basically, we work in a mode of bring your own LLM. So we're using a package named Light LLM, which gives you a unified interface to any LLM. And then you can choose what you want to work with. So you can work with an on-prem model, you can work with OpenAI, with Azure, with Bedrock. Like Light LLM supports probably most of the models. And I think anyone which is creating a model now is adding a support for Light LLM. So it's basically support any LLM. Yeah.
And have you found specific LLM that is the best?
I think, I don't know, like we work a lot with OpenAI, they are really good, and then I think the Azure OpenAI also has a good model. This is my personal experience. Yeah.
Arik, just a clarification, you said that the Homes is running in a pod. Is it in a pod where the Robusta?
It's a separate pod.
Yeah, but on the let's call it on the same cluster where Robusta.
Yeah.
The engine is actually running.
Yeah.
It's not on the where the agent is running.
Yeah.
Okay.
It's running on like on each monitored cluster because it's issuing commands on this cluster.
So the follow-up to that, sorry, kind of streaming a couple of different questions. So then your LLM lives on the cluster and you as the cluster provides the compute to do the
So the LLM doesn't live in the cluster, like only the agent that is doing the command. So the data flow is like Holmes is getting a command to do an investigation. On this case, he ran kubectl get PVC-OYAM, and then he sends it to the LLM, which runs remotely. So the LLM can run in Azure, and then the response goes back to Holmes, and then this is like the LLM.
You farm it off to whichever provider you want to use, whether it's internal or.
Yeah, if you run the LLM locally, so yeah.
And then how far deep does it go? So like if I had part that was failing on accepting requests, right? Now there's a little bit of a dispute. Is this part itself failing? Is it the networking? Is it going to be able to spin up a net shoot and say I called from the net shoot and I couldn't reach it? I tried it on the servers, interrogated the Nginx logs.
So it depends. So like Holmes doesn't know anything, there is not enough data. So if it appears on the log that there is a problem on the network and you have a tool to explore what's the status of the network, Holmes will do it. Like we did an experiment not too long ago about some pods that are calling a load balancer, and sometimes the load balancer backend are down. And Holmes was able to pick it up automatically because there was a message that made sense in the log.
So I guess what I'm saying is like, then you're going to add, I think you called it tools.
Yeah.
You're going to add those different tools to extend the capability of where it can drive its data.
Yeah.
Okay.
And then if there is not enough data in the in the log or whatever the data, so you can provide custom instructions. So you as a developer, you probably know my application is dependent on the database, and then if you see weird stuff on the application, you should go and check the database, and Holmes knows to follow those instructions.
Arik, we had a customer last week, and it comes back to the question of hallucinations earlier, where we were doing a proof of concept with them. And they came back and said, look, honestly, we weren't that impressed. It didn't find a problem. So we asked them to show us, and it was talked to a Kafka structure, and it said that the Kafka environment was down.
Yeah.
And the customer said, he got it wrong. And I mean, having looked, we said, no, the Kafka environment wasn't down. You just happened to take it there. So you talked to the engineers. So yeah, we knew it was down. You took it there for a change. So guys, that's kind of not a hallucination. It got the problem. Now with a connection to Kafka, we could get a query on the Kafka stores and documents. We'll tell you exactly what was going on. And with the links to their changes, we can run change. So yeah, it's really easy to get a hallucination, but actually the SRE team in this case didn't know that this change had occurred, and it was kind of predicting it right.
So how do you protect the secrets? Because you're going to add the context to the query, to the LLM. So
How do you protect what?
The secrets.
the secret? Yeah. How do
No,
you
Holmes
protect-
doesn't have access to secrets. Like not found and not overactive. Like we prevent it in the cluster. You cannot restrict.
Oh, it doesn't really secret at all.
Yeah.
So if it happens that the issue is in the secrets, then
Holmes will tell you, I don't have permission to read secrets,
okay.
and then you can like customize the cluster role, but in your hand. Okay, next. So we kind of discussed it now sometimes you need like an expert knowledge to know what's wrong with your system. Like if you don't know what's the structure, like what's the architecture, you won't be able to solve it. So Holmes can get instructions, like you can feed it with the company data source, and then to do investigations according to what you tell him. I can show you how it looks. Okay, so basically this alert says that web users fail to get OTP SMS messages. And this is like a platform where you have, during the checkout, the system sends you a one-time password. And then you have like a publisher that sends the message to a Kafka queue. And then there is a consumer which sends the SMS message. And then we're getting alerts from the checkout service that something is not working. And when I go to Holmes, it doesn't give me a good answer. Like it tells me image without OTP service configuration. It's not the real cause. So I'm the developer, and I know that basically when this happens, you need to check the Kafka topic named OTP messages. And if you have a lag there, you need to check what's happening with the consumer. So I'm giving Holmes this instruction, and this also is based on the tool calling capability. And now, if I go and run the investigation again, hopefully Holmes will tell me what is the actual reason, which is the SMS messaging service is down. Okay, he didn't find Kafka because
Question on mine is asking, are there any plans to include security scans for images in the cluster?
no, not at all. Oh. Yeah. This is demo God going against. Yeah, I missed something. Okay, let's move to the other demo. So here I have an account service. Doesn't have any alert or anything, but I did get a complaint from support that something is wrong with it. When I first check it with Holmes, so Holmes said it's healthy, nothing in the log, nothing in the events. But I'm the developer, I know that this application talks to a database. So I'm going to add an instructions to check the DB when you check the health of this app. Okay, so Holmes is saying the account service is healthy without any issues. However, the Supper-based deployment is getting oomphy. So he was able to use my instructions and tell me the account service is fine, but the issue is on the database. And this is like really an amazing capability. So if I'm going to feed Holmes with all the knowledge the engineers have, I'm getting an agent that really can do human-like investigation and just provide the root cause basically. I won't say as good as a human, but he can really, this is really a game changer. So what we're building now, we're adding capability to Horns. We recently added an API to Robusta that you can push events which are not Kubernetes failure. So if you have AWS issues or anything, you can send it to Robusta. And we want Horns to be able to analyze those as well. We're building a lot more tools. So Horns can out of the box will be able to give a wide coverage. And then the last thing we work on is basically iterative investigation. So we want Horns to start the investigation from any given service, and then using instructions walk down the dependency path, and then try to recursively investigate until he gets the root cause wherever it is. And I think once we have that, this is really the holy grail of automatic investigation. This can really take what a human might take many hours to find and find it in a minute. And lastly, this is just the beginning. So LLMs are just just beginning. They are getting better every day. The amount of tools in the ecosystem is growing very fast. And we already see assisted workflow everywhere. And I think we're just going to see more and more. And yeah, we think this is the future. Yeah, thank you.
Thank you.
Any more questions or thoughts? Yeah.
Question is around the costs. How much more does it cost running the AI agent in your cluster?
Yeah, that's a good question. So we did some measurements, and we saw that today each investigation costs about 5 cents. And I think as we go forward, it will become much cheaper.
Significant sense.
Like US dollars. Yes. What will I get there? Yeah.
Would Homes GPT be able to help improve the cluster? So besides troubleshooting, diagnosing issues, like let's say cost optimization or like moving workloads or that type of scenario, would be able to give suggestions on that.
So I think so. Like LLMs are not good at math. So like we have a utility for improving cloud costs, but it's basically based on looking on Prometheus metrics and then comparing like usage to the configuration. But at its base, this is like a mathematical question, and Holmes doesn't know. Like not Holmes, LLMs are not good at doing math.
So one of the core open source projects that Robusta sponsors is called KRR. KRR is Kubernetes Resource Recommender. So it listens to all of this telemetry and it gives you projections on how you can optimize your time, CPU and memory, cloud costs. Arik can probably show it as well. And it does it in a number of different ways. But in the UI, it can also give you, much like you saw the command to change VPC, it can give you the YAML to make the change to what it means. And that's based on real data that typically is gathered over a period of teams.
Okay, I think we've got the same question. So at the moment, we've got KRA, but you have to manually go apply those changes.
Mm-hmm.
Is there any plans that you can
Auto-apply the
KRR apply or?
Yeah. So KRR is like the resource recommendation utility. It's also an open source. And we are thinking a lot about implementing an auto-apply. Currently, KRR just, for those who are not familiar with it, it just gives you a report of this is your application. You configure that it needs 1 CPU. But in practice, it uses only a half, so go and fix it. And yeah, we want to add like capability using a mutation webhook that will automatically apply those recommendations.
We're getting different feedback from different organizations. Some say do it, and some say, no, never do it. So all feedback is welcome.
I'm just thinking that if you look at the recommendation and you, as the human intervention, you can say, apply it, and because in a lot of cases you would have the same user that has signed on to Robusta that would have access to the cluster as well. But I assume there is some nuances there that you have to ensure that before you can.
Yeah.
It's a big I trust you button.
Yeah. Only that info.
The beauty is, of course, you put a change tracking as well. Yeah. So you see that it's been done.
Yeah.
Automatically.
I'm not a developer, but I was just thinking, you speak about, so for example, you've got homes working within a pod. Again, not a developer, so you've got two pods. These pods need to talk to each other, and they have dependencies within each other. But when it's within that isolated environment, it's trying to interrogate what it cannot see beyond the walls of that environment. Am I correct? So it's sitting within it's restricted as what it can see and give feedback on. Can homes interrogate from both sides? So say for example you have it in a pod, and then there's the other side, where it's meant to receive information from another environment or receive requests or responses. Does it, or are there plans to make homes act as an agent interrogating itself from both sides of the window? Does that make sense?
So, like, you mean, so few homes instances will do a collaboration, like each one is gathering data from a different place?
Pretty much. So in different environments. Say, for example, you're using two different services, and you've got homes in one service and homes in another service, but they're isolated.
Yeah, we didn't think of it, but I guess it's doable. It's just another tool. So like you could tell homes this is a tool to get information from homes from another cluster, and then you can get.
It's investigation, discussion, then decision, right?
Yeah, but if you boil it down to kind of Kubernetes ecosystem, you've already got things like pod and namespaces and clusters. Robusta can operate across all those boundaries, but to your point, if they're isolated today now, could be really interesting.
So I have a somebody has a question. So one question. So I try to understand. So how does hosts know that something is a problem? So if you run a kubectl command, it will list the pods which are healthy and the pods which are not healthy. How would it learn that the non-healthy message is a problem?
So it's just text-based. So like Kubernetes has human readable error messages, and Holmes can know to read. Like he understands text. Okay. And like as long as you have text that makes sense in the log, in the Kubernetes events, in the kubectl described in any tool, Holmes will be able to understand it. And like the engineers that wrote these messages aimed at people. They want people to be able to understand, and now Holmes can pick it up.
That makes sense.
You want to ask him?
Yes, in the demo, one of your pods an issue, and it said that there wasn't enough space in the cluster, right?
There wasn't enough CPU and memory.
Right now, that is circumstantial, right? If I was an engineer, because yes, you look at it from the obvious answer is you're over allocated in this cluster, but the root cause of that might not be, or the remediation might not be adding another node. It might be going back and seeing, are there multiple services that are misbehaving, and because there's so many of them up and running, it's hogging the CPU. So the adding an extra node is not the answer. It's looking at that, or you've got bad developer practices in the system, and so pushing back on your developers to say, right size your workloads is a more feasible solution. So where do you see it? Can it figure that out firstly? Sorry. And then secondly, where do you see that as the extenuation? Would you be adding more of those? I thought of them as playbooks, but I think I can't remember what those called. Tools. But where you put in like instructions. Yeah, instructions. Yeah. Would you be adding? Would you be like is that what we starting to do that?
Yeah, so
those kind of
if
things?
you're at your company, you're responsible for how you want your developers to handle such issues. So you can add instructions whenever you get not enough resources. First, you need to check if there are not all your applications are right side, and then if they are not, you need to add a node to the cluster. If they are not right side, you need to like configure them properly. So this would be the right workflow. Okay. So like Holmes doesn't know how to do it yet, and maybe it's not the right workflow for every company. So one company would say just add another node automatically.
The context of today's conversation really was to talk about Arik's journey and how we're developing some AI capabilities. In the UI, Arik showed you some of the platform capabilities that have been in the product for the last 18 months, 2 years. To your question earlier, there are features set up for infrastructure people for platform engineers, and people for application development. And where you've got a tab called nodes, and you've got this KRI capability, you can see very easily within the nodes capability whether or not a node is correctly provisioned from CPU and memory perspective. With the KRI, you can see the workloads that are very much. So it's a case of capabilities there in the platform. Do you want something within the UI, or do you want to try and get homes to do it? And you can't do it both ways, but most of our infrastructure people will go and have a look at the nodes and see how CPU and memory are allocated, whether they need to scale up or scale down.
Yeah, the reason I ask this is just to understand where do you see us playing with the tool? What kind of direction do we go? Because if I had to put this, it's an awesome tool, right? And I imagine that we want to expose it at some stage to the application developers who run on these clusters. And if they're told they need another node, it's AI, it's smart enough, it was able to detect it, and they're going to take that course of action. Then we understand how to use the tool and what level we empower developers to do those kind of things. So we are more on the system side, roll it back and say, this is more for us at this stage.
No, I think this is actually meant for developers, or like basically Holmes will be as smart as the equipment you give him. So if you give him enough tools and enough company knowledge, it can be really smart. I don't think it will ever be able to replace people. There will always be issues you need a human to look at. But for us, if we will be able to reduce the number of tickets developer open by 80%, and then we will be very happy. So if 80% of the time a developer or an SRE or someone from the NOC can click a button and get the answer in under a minute, instead of opening a ticket to the platform team and wait until they come back, this would be a huge success. It makes everyone way more productive, and it's less uptime.
That's what we're seeing going is the on-call. We've got paged at 2 o'clock in the morning. I've got to get my brain in gear, go off and use Homes to get me orientated where the problem is. See that as a really big win.
Yeah.
So I just have a lot of LLM questions. Right now it sounds like you're mostly using OpenAI or Azure OpenAI, right? Do you see value in fine-tuning for specific data, since you already have access to those fine-tuned?
We didn't use fine-tuning yet. I think at the moment, being able to analyze text is giving very good result. But it's definitely a direction we're thinking about a lot.
One of the questions there. So, the cloud makes a landscape issue. I think most of the people who have Kubernetes clusters have a lot of other projects installed. So does Home GPT also have concepts of those? Cluster autoscaler. Okay. You've got Prometheus there, you've got SDO there that could cause issues. Does it take that into consideration, or does it just purely look at Kubernetes native objects? Because if you fine-tune LLM, tell it that we have all of these other services that's in play that you should consider.
Yeah, so definitely Holmes should interact with all your services. So if you have a service mesh in the cluster, this is one of the best source of information of what happened happens network-wide. So this is like one of the first tools we are about to add. And it like, the more tools you add, the better homes will be. And like, it's not limited to Kubernetes resource only. Definitely not.
So, quick one. When it comes to creating agents, I've found it's also as part to tell the GPT what not to do. So negative prompts. So when you put this into a business, do you analyze what the business needs are and then restrict it and train it according to how that business runs and how that team runs? Or is it that's how Homes is and you improve that as, you know, every business has different policies. And different industries have different policies and different set of operating procedures. And I'm not going to say IT is IT because I don't know. I have a team of devs, and just thinking from a managerial point of view, it's very seldom you'll get a developer that will come and say, "There's this new tool that's going to make life easier." So it's going to replace us, right? But it's been hard, difficult with my guys. And like, well, the guys that use it will replace the guys that don't. So when it comes to bringing it into a large or small business, you know, what is your sweet spot where this really makes an impact in terms of company size and how customized you make it for that company?
So we don't customize the prompt for company. We have like a prompt that is generic enough to give value to all companies, and then to provide company internal policies, we have the instruction. So you can say, and Holmes, like the instructions kind of override the general prompt, and then Holmes will consider both.
Okay, all right.
Okay.
Some more questions? Yeah. But I'm sure we've all learned a lot today. Thank you so much. It's awesome. So Arik's from Tel Aviv, all the way here, just from Techno. Yeah, again for this week. So yeah, if you want to chat to him more about what they do, specific questions, yeah, please feel free to chat to him. This. There's more pizza, more beer, more drinks. Please help yourselves.
We're going to take the t-shirts on the hats back.
Yes.
Thanks.
Thanks, Arik. It was awesome.
Thank you.